Okay, so this will be 5.3, logarithms and logarithmic functions. This will be day number 2. In day 2 video, you are going to see how to solve logarithmic and natural log equations with a calculator. Okay, so yesterday you kind of learned how to do them without. Now I'm going to show you how to do them with a calculator, okay? So think about what you did yesterday. Let's apply that to today, and let's get started. Okay, so like before, the advice, I kind of gave you some advice, and I thought it was very, very important to write down. I'm going to do the same thing. When I look at these type of equations, notice letter D, I have 10 to the x. Letter F, I have the log of x. And when I want to solve them with a calculator, I'm always thinking two things. The two things that I'm thinking, let me take a second to get that to load. Okay, here are the two things, the most important things that you're going to have to remember in order to solve these with a calculator. The first one, if it's written as an exponent, I'm thinking to do the inverse, which is to take the log or natural log of both sides. Okay, so I'm always thinking of the inverse. Think, how do you undo a square? Well, you do the inverse, which is a square root. How do you undo a cube? Well, the inverse is a cubed root. So I'm thinking, in order to solve an equation, I'm just going to do what I've been doing my entire life. I'm doing the inverse. What undoes it? So when it's written as an exponent, the inverse is to take the log or natural log. And conversely, if it's written as a log or a natural log, the inverse is to write it as an exponent. So I'm looking at this one right here and this one right here. I'm seeing it's written as an exponent, so the inverse would be to take the log of both sides. Why would I say to take the log of both sides and not the natural log of both sides? Well, you should be able to say to yourself, well, they are in base 10. I know logarithms are in base 10, so that's why I'm going to take the log of both sides. Okay, so let me show you. Take a look, letter D. Like I said, it's written as an exponent. I'm thinking take the log or natural log. So because it's in base 10, I'm going to take the log of both sides. Left-hand side, because they are inverses of each other, I'm simply left with x. Right-hand side, I'm left with the log of 4.6. Well, I think in my calculator, I can hit log 4.6 and hit equals, and I get 0.66. Okay, so letter E. Same deal. It's written as an exponent. I'm thinking that I have to take the log of both sides. Left-hand side, they cancel each other out. Right-hand side, I have the log of 220. In my calculator, when I take the log of 220, I get x is 2.34. Okay, so hopefully so far so good. But notice letters F and letters G, it's written as a logarithm. Now I'm thinking, okay, it's written as a log. The inverse is to absolutely write that as an exponent. Okay, so based on what we learned yesterday, I know and I understand that logarithms are, if there's nothing written, it's understood to be in base 10. So watch this. I can write it as an exponent saying 10 to the negative 1.3 power is equal to x. Think about what we did yesterday. Refresh your memory if you need to. That's how I write it as an exponent, and then I'm going to do 10 to the negative 1.3 in my calculator and get 0.05. Okay, so hopefully that went okay. Letter G, pretty much the same deal. It's understood to be in base 10. It's written as a logarithm. I know the inverse is to write it as an exponent. So 10 to the 4.35 equals x. Do that in your calculator, and voila, 22,387.21 is what pops out. Hopefully that went okay. Great news for all of you. Natural log, it's the same deal. Same rules apply. So I'm going to maybe zip through this a little bit. Think e to the y equals x. Notice if I have y equals ln of x, nothing written there, it's understood to be in base e. Okay, exponent, when we talk about logarithmic functions, the natural log, they're understood to be in base e. So letter H, simplify without a calculator. So basically I'm asking you what do these three equal? So same deal. I see it's written as a natural log. I know the inverse is to write it as an exponent. Remember, it's understood, if there's nothing written there, it's understood to be in base e. Okay, so that's why I knew e to the x is equal to e squared. Think, same deal. Whenever I have bases that are equal to each other, I know I can drop the base and set the exponents equal to each other, so I get x is 2. Letter I, same deal. Rewrite it as an exponent. Obviously, x equals 1. Letter J, same deal. And obviously, x equals the square root of 3. So hopefully, very, very, very simple, as long as you remember inverses of each other. So take a look. I gave you some to try. This case, I gave you a natural log. So I'm going to go a little bit quicker because you should have maybe an understanding right now. Letter K, it's written as a natural log. I know the inverse is to write it as an exponent. So I'm going to write that as an exponent, do that in my calculator, and voila, there it is. Letter L, same deal, write it as an exponent, and solve it, voila. Letter M, now it's written as an exponent. I know the inverse is to take the log or the natural log of both sides. I know in this case it's in base E, so I know what I should do is take the natural log of both sides. That gives me x equals the natural log of 7.68. I do that in my calculator to get 2.04. Letter N, try that. Natural log, got it, got it, got it, got it, got it. Okay, so hopefully you got them. Solving with and without a calculator. Remember what inverses of each other are. And think about inverses as we get into tomorrow, which I believe is graphing them. So hopefully you got it. We're going to build. So if you're getting a little bit behind, throw up the white flag. I will gladly help you. And good job.